All right. Coming up next, now that we sort of know our way around some decimal stuff, let's do some things with decimals. So let's run through all the operations. Let's see if we can get through addition, subtraction, multiplication, and division all in one video. I believe in us. Let's see. So addition, subtraction. The main thing is line up the decimal. So if you're adding and subtracting, I'll do kind of maybe one of each. Let's do 2.73 plus 15.065. So we're talking kind of the classic setup, stacking them up and adding them together. So the main thing is you need to make sure your place values line up, which means you have to have the decimal place in sync. And then, so in this case, where we have one of our numbers sort of has 2 decimal places, the other has 3, that's kind of by definition out of sync. Well, I can, of course, throw extra zeros on to the end of my my number that sort of is short a few decimal places. And then I'm just, adding columns, right? Just like we would do. 5 and 0 is 5, 6 and 3 is 9, 0 and 7 is 7, 5 and 2 is 7, so 17.795. Done and done. No big deal. Same kind of rules with subtraction. The only thing in theory, right, if you start to maybe mix up, let's do negative 72.5 minus 6.98, let's say. So this is a negative number, and we're subtracting off of it. So what that means is we're going to get a bigger negative value, right? I mean, this is going to be, 72.5. This is almost 7. This is going to be kind of just shy of a negative 79. So what I'm actually going to set up is addition. I'm going to set up 72.5. I guess in this case, 0.5 is 0. Plus 6.98. I'm going to add these guys together, and then my answer will be negative. 0 and 8 is 8. 9 and 5, 14. Carry this one up. Carrying and borrowing, of course. That stuff still is in play. 3, 6, 9. 79.48. So because it's a negative number minus that, our final answer here is also going to be negative. So stack them, add them, get your stuff in sync, and go from there. Multiplication. You do not need to line up your decimals when you multiply. You are going to do, again, sort of stacked multiplication. The sort of classic, again. Let's say something like 6.52. Let's times it by, I don't know, 7.8 or something, right? This is kind of random. This is sort of 6.5 times 8-ish. 6 times 8, 48. This is going to end up 50-ish, somewhere around 50. What we're going to do, so set it up with our decimals, even though in some sense when we multiply, the decimal places aren't really going to have an impact. You don't need to line up the decimals. So, you might be tempted to sort of do like we did here and line them up and put some extra zeros on there. It's not really going to get you anything, right? Because you're just going to sort of get some extra zeros. They're not really going to have an impact. So we'll do our usual multiplication. 2 and 6, 16, 140, 41, 6 and 8, 48, 2, so 52. Round 2, so coming down here we need a 0 as a placeholder. 7 and 2, 14. What's up? 7, 5, 35, 36. 6, 42. 3, 45. So add the 6, right? 5. This is 8. And then this is 5, right? Carry this up. So we said we kind of expected to end up around 50, so in that sense it must be that this is 50.856. That's not a particularly scientific strategy. They kind of just like feel it out strategy. So how do we know that's where the decimal is going to go in our answer? I mean, you might say, well, there's 2 here and there's 1 here, so maybe it should be 1 or maybe it should be 2. And so what you're going to do is you count the total number of decimal places across sort of both of your original numbers. So there are sort of 3 decimals across those 2 numbers, right? 1, 2, 3, 3 decimal places, and so you account for each of those decimal places in your final answer. So you carry your decimal over 1, 2, 3 places, so 50.856. So 856, all those values are to the right of the decimal, and then again that kind of syncs up with what we were expecting, right? We were expecting to sort of end up with something around 50, and that, checks out with what we've got there. Same kind of thing. I guess we'll sort of do another one. Let's do, well, I don't know, we can do some negative stuff. Maybe 0.05. Let's multiply that by 16.3. So a couple different ways to write this. I mean, you have definitely some like decimal values here. I'm going to throw the 16.3 on top, and then so 0.05, I mean, I guess I should do 0.05. We're multiplying these guys together. Of course, a negative times a positive will be negative. We'll just sort of take a note of that and just make sure we include it in our final answer. This is an interesting one where, I'll do, of course, my first run through, 5 and 3, 15, 6 and 5, 30, 31, 3 and 1, 5, plus 3 is 8. Okay, in theory, I could do 2 more rounds, but I'm just going to get a bunch of zeros, right? I mean, just like all the zeros I can handle, that's not really going to get me anything. This is kind of unnecessary. So this is really 815. I have in my original, so 1, 2, 3 decimal places again, not necessarily on purpose. So that means I've got 815. I'm going to come over 1, 2, 3. In theory, I guess maybe I should put a 0 in front of it. So this is again, I have a negative 0.815, something like that. So we get a pretty small value. I mean, you might say, 5 times 16, right, should kind of end up around 80. But of course, with these decimal places here, we actually get a smaller number than what we started with. So if that can happen, that's fine. The process here, right, the steps, the same as what you would do with whole numbers. You're just accounting for your decimals in your final answer. So that was addition, subtraction, that was multiplication. What have we left out? Well, it must be division. And division is just going to be long division, honestly. So it's long division, but what we're going to do is we're going to shift our decimal place kind of as needed. So, for example, let's start with something maybe we're going to have a pretty good idea of what to expect. I don't know. Well, maybe 62.52. Let's divide it by 0.15. I'm sorry, 1.5. So this setup, right, initially is going to look like 1.5 on the outside, and then I've got 62.52 on the inside. Now, the issue here, besides just sort of a general sense of like, I don't know, I would rather not have to deal with this. Isn't this why we have calculators? Yeah, sure, you can do this with a calculator. The point is to try to make sure you can do it by hand in a pinch, of course, right? So the problem is I don't really want to do, 1.5 goes into 6 like 4 times. So should this be a 4? And then it goes into 2 like once? But then I have 0.5 left over? There's just all sorts of strange things happening here that would make trying to divide a decimal into whole numbers, it just really wouldn't work. Like, let's just not do that. So instead of that, what I'm going to do is I don't really want to work with 1.5. I can work with 15. Give me something I can work with. I can work with 15. So, okay, well, that would just mean just like shifting this over 1. Well, I don't know. Can we just shift everything over 1? And the answer is, yeah, that's fine, as long as you also shift your value, your decimal place over 1 underneath your division, right? You just need to sort of match that same move. So that's allowed. That's okay. We can do that. as long as we just sort of match the behavior. So this is equivalent mathematically to 15 going into 625.2. So that's just what we're going to work with. We're just going to do that problem instead. And the answer is going to be the same. We're not going to have to do any sort of conversion at the end of it. We're just going to kind of get what we get. 15 does not go into 6, but it goes into 62, right? It's going to go in there 4 times. That would be 60. If we subtract, we get a 2. Bring this down, 25. Go in there once, 15. So that's going to give us 10. 102, not the most natural number in the world. Our decimal place sort of goes up top. Let's do 15 into 102. 15 is going to go, what, 6 times? Is going to get us 90, I guess. And then that would be 12 left over. We subtract 12. I'm out of values, but of course I'm not. I can bring down as many zeros as it takes. We're in this till the end. As many zeros as it takes. And lucky for us, I think it's only going to take this one. Actually, maybe that's a little bit of an anticlimax. So this is going to be 8. 15 times 8. Right? We did times 4 was 60, so then times 8 would be 120. And that's going to be our answer. So 41.68. And that's what we've got, right? So we just are sort of doing the long division, and we're just going to shift these values around kind of as needed. You know, you could get stuff where you're doing, you know, maybe a little bit more of a trivial kind of multiplication. Not trivial, I mean, let's not make it seem like any of these is truly trivial. But, you know, you could do something like 50.4 divide by, you know, 0.6 or something instead, right? Or, so that's going to look like, right, 0.6, 50.4, but again, we're sort of shifting everything kind of over once. So this is really going to be the same as a whole number 6 going into 504, and we'll throw a little 0.0 on there just to see if we need it. Right, 6 into 50, 8, 48, we subtract, oh, we're actually not going to need it, 24, goes in 84 times, who knew, okay, and that's a 0, right, so we're done. So that's going to be just 84 on the nose. So don't try to actually do the division using the decimal numbers, just do a quick sort of shift, rewrite, get some whole numbers on the outside, and then sort of work the division from there. That's the basics of it. And there we go, one video. Addition, subtraction, multiplication, and division. Everything you could ask for.